Hello everyone and welcome to our channel. In today's video, we are going to delve into the fascinating world of beer production and discover how one of the oldest and most appreciated drinks on the planet is made. Did you know that more than 2,000 billion hectoliters of beer are produced annually around the world? That's right, this incredible figure reflects the popularity and importance of this drink in various cultures and societies. Throughout this video, we will explore each stage of the production process from the barley fields, the selection and milling of the grains, through fermentation, until reaching the final bottling. So, if you are a beer lover or just curious to know how it is made, this video is for you. Get ready to discover everything you ever wanted to know about beer production and more. Let's get started. Ingredients. Beer production begins with a careful selection of essential ingredients. The first and most fundamental is water, which makes up more than 90% of the content of beer and can significantly influence its flavor and quality. Next, we have malt, which is usually derived from barley. Malt is responsible for providing the sugars necessary for fermentation and also contributes to the distinctive flavors and colors of beer. Then there are hops, flowers that not only provide the beer's characteristic bitterness, balancing the sweetness of the malt, but also act as natural preservatives and add complex aromas and flavors, from citrus to herbal. The fourth key ingredient is yeast, the microorganism that converts malt sugars into alcohol and carbon dioxide, essential for fermentation. In addition to these four main ingredients, brewers often add other elements to create unique styles and flavors, such as fruits, spices, herbs, and honey. Each of these ingredients must be selected and combined with precision to produce a balanced, high-quality beer, reflecting both brewing tradition and modern innovation. Malted. The malting process is the first step in the production of malt, one of the main ingredients in brewing beer. Barley is soaked in water for a specific period of time, usually between 8 and 12 hours. This soaking step helps hydrate the beans and prepare them for the next step in the process. After soaking, the barley grains are placed in a germination room, where they are allowed to germinate. During this process, the grains begin to sprout and develop natural enzymes that are necessary to convert starch into fermentable sugars during mashing and brewing. During germination, the temperature and humidity of the environment are carefully controlled to promote uniform sprout growth and prevent grain decay. Aeration and turning systems can be used to ensure even distribution of heat and moisture. Once the sprouts reach a specific length and the grains have developed the necessary enzymes, germination is stopped by stopping the growth of the sprouts. This is achieved by heating the beans in special ovens, in a process known as drying or roasting. The sprouted grains are transferred to drying ovens, where they are dried using hot air. The temperature is carefully controlled to avoid the formation of unwanted flavors and to achieve the desired degree of roasting. The degree of roasting will influence the color and final flavor of the malt. Once the malting process is complete, the barley grains are known as malt and are ready to be used in brewing beer. Grinding. Milling is a crucial stage in the production process, as it prepares the malt grains for the efficient extraction of sugars and other compounds during the mashing process. The malt is fed into a roller mill, which consists of two rotating rollers that grind the malt grains together. The distance between the rollers is adjusted to control the size of the crushed grains. It is important to achieve a uniform grain size to ensure efficient extraction during mashing. The resulting crushed grains are known as grist. Once ground, the crushed malt grains are ready to be used in mashing. Maceration. Mashing is a fundamental stage in the beer-making process, where malt is combined with hot water to extract sugars, proteins, and other soluble compounds that will later be fermented by yeast. First, it is mixed with hot water in a container called a macerator. Generally, temperatures between 62 degrees Celsius and 72 degrees Celsius are used to activate the enzymes present in the grains, which will break down the starches into fermentable sugars. During maceration, a type of slurry called must is formed, which is a mixture of water and grain extracts. This wort is continuously agitated to ensure uniform distribution of nutrients and water-soluble compounds. Once the proper temperature and mashing time has been reached, the resulting wort is filtered to separate the solids from the liquids. The remaining solids, known as grain residue, can be collected and used as animal feed or for other purposes. The filtered liquid, now rich in fermentable sugars and other compounds, is called sweet wort. This wort is transferred to the next step of the brewing process, the boil, where hops are added and boiled to add bitterness and aroma, as well as to sterilize the wort. Cooking the wort and cooling. The resulting wort is transferred to the boiling vessel, which is typically a stainless steel kettle. This boiler is equipped with controlled heating systems to increase the temperature of the wort. The wort is gradually heated until it reaches the boiling point, which is generally around 100 degrees Celsius. During this process, any unwanted microorganisms present in the wort are eliminated, and sugars and other soluble compounds are concentrated. Once the wort has reached the boiling point, the hops are added. These can be in the form of whole hop flowers, hop pellets, or hop extract. Hops add bitterness, aroma, and flavor to beer, and their cooking time in the wort affects how these characteristics develop. The wort is boiled with the hops for a specific period of time, which can vary depending on the beer recipe. During boiling, several important chemical processes occur, such as the isomerization of hop alpha acids, which contribute to the bitterness of beer, as well as the evaporation of water, which concentrates the wort and helps sterilize it. In addition to hops, other ingredients can be added to the wort during the boil, such as additional spices, fruits, or sugars, to add flavor, complexity, and aroma to the beer. Once the boil is complete, the wort is quickly cooled to stop hop activity and prevent unwanted flavors from forming. This can be achieved by using a heat exchanger or plate chiller, which transfer heat from the wort to cold water. Fermentation. Before fermentation begins, the fermenter is thoroughly cleaned and disinfected to ensure a sterile environment. This is crucial to prevent bacterial contamination and ensure that fermentation goes smoothly. Once the wort has been cooled and transferred to the fermenter, the selected yeast is added. Yeast is the key agent in fermentation, as it is responsible for converting the sugars in the wort into alcohol and carbon dioxide. Depending on the style of beer being brewed, a specific variety of yeast may be used to contribute to the desired flavor and aroma characteristics. Once the yeast is added to the wort, the yeast begins to consume the sugars present in the wort and produce alcohol and carbon dioxide as byproducts. This process can take several days or even weeks, depending on the yeast strain, fermentation temperature, and other factors. It is important to control the temperature of the wort to ensure optimal conditions for the yeast. Fermentation temperature may vary depending on the yeast strain used. Precise temperature control helps control fermentation speed and maintain yeast health, which in turn influences the flavor and aroma profile of the final beer. The gravity of the wort is regularly monitored using a hydrometer or refractometer to determine the progress. This helps brewers calculate alcohol percentage and determine when fermentation is complete. Maturation. Once fermentation is complete, the beer is transferred to another tank for maturation. During this stage, the beer is allowed to rest at colder temperatures, typically between -1 degree Celsius and 4 degrees Celsius. This low temperature helps the beer mature slowly and develop its characteristic flavors and aromas. During the maturation process, the beer is also clarified. This involves removing any sediment or suspended particles that may affect the clarity and stability of the beer. This is achieved through filtration or through the use of fining agents. After maturation, the beer can be carbonated. This involves adding carbon dioxide to create the desired level of carbonation and effervescence. This is achieved through refermentation in bottle or keg, or by direct injection of CO2. Bottling and packaging. The bottling and packaging phase is carried out in breweries using automatic filling systems, guaranteeing adequate and uniform filling of each container. Bottles or cans are labeled to provide information about the product, such as the beer name, style, alcohol content, nutritional information, and any other information relevant to the consumer. Once filled and labeled, the containers are grouped and packed in boxes for easy transportation and storage. Once these stages are completed, the product is ready for distribution, where consumers can enjoy it and appreciate the final result of this wonderful process that is beer production. And as we come to the end of this fascinating tour of the beer making process, I hope you enjoyed sharing it with you as much as I did. If you like this video, I invite you to subscribe to our channel so you don't miss a single new content. Also, what did you think of this video? Would you like to see more about the production of other products? Leave us your comments below. Your opinion is very valuable to us. Thank you for joining us on this beer adventure, and until the next video,